Welcome, everyone. My name is Jordi Ricard, and it's a pleasure to introduce the next session of our Journey to the Cloud series. Today, we will talk about Oracle Cloud, but you will find online the previous sessions we did before. With that, it's my pleasure to hand over the session to Oscar Martinez, head of our Big Data and Cloud practice. Oscar, can you share the highlights of this series of webinars?
Thanks, Jordi. Sure. Let me get right into it. So, as Jordi mentioned, this is the 7th session we've been conducting since we started this series more than a year and a half ago. We started with Azure, where Manuel Mas basically showed us how to build a data lakehouse with signups. Since then, things have changed. Fabric has been introduced. So we should probably do a updating of that one. But let's get to finishing first the series with all the technologies that we want to cover. Today is Oracle, and then we'll see probably cloud technologies change so much that most of the things that we said 1 year and a half ago need to be updated, not only for Azure, but also for the rest of the stack. After Azure, we did Google Cloud, where Victor Colomé also showed how to use BigQuery and how to basically ingest data in real time using the cloud functions. It is like a customer project we did a while ago, and we basically show you the lesson learned and the architecture that was implemented for that one. In the third session that we had, which was about AWS, Esteba showed us how to build a data lakehouse with modern DevOps practices on the AWS stack. The fourth session was Dremio. In that session, my colleague Alex and myself show you basically a success story that we have with one of our customers in Europe, where we basically use Dremio to fix some issues they had when querying a large data set with billions of rows. That was possible to be done faster with Dremio than the traditional method with a relational database. In the fifth session, we saw Cloudera. So with Cloudera, we saw the new, the new is not new anymore. It's 2 years ago or maybe even 3 years ago when Cloudera released the Cloudera Public Cloud, which basically uses native technologies like on the cloud, like the cloud, basically the cloud storage, S3 or Azure Data Lake storage or Google Cloud storage. And basically that replaces the traditional HDFS. And we see how Cloudera has even improved the services, introducing Kubernetes-like running of some of the services in the stack, like Spark, Hive, Impala, and so on. So it's now a very interesting product that many customers are already adopting. In the previous session, we dedicated it to Snowflake. Snowflake is probably the most trendy and the one that has had the largest increase on usage and popularity in the last 5 years. And it's one that is taking by storm the cloud data warehouse landscape. And we have more and more customers embracing Snowflake. And today, the turn is for Oracle Cloud. Yes, Oracle also has a say on the Lakehouse story and on the Lakehouse landscape. Oracle is not only ERP or similar systems or a database. It's much more than that. Oracle has its own Oracle Cloud, and using the services available on Oracle Cloud, it is perfectly possible to build a full-fledged data lakehouse that has nothing to envy to the ones of the competitors. Okay, so without further ado, let me hand it over to Jose, who will basically start the discussion about how and what Oracle can do in this lakehouse. All yours, Jose.
Thank you, Oscar. Now I'm going to talk you about Oracle Cloud, one of the most influential and powerful clouds in the technology industry. In this part, we will explore how a data lakehouse architecture based in Oracle Cloud is, its key features and benefits, and how it is transforming the enterprise technology landscape. For this presentation, we will discover the key aspects of Oracle Cloud, such as high-performance computing, where Oracle provides a computing resource that allows us to run a wide range of workloads. This technology offers the ability to perform calculations and computational processes at a speed and scale significantly greater than the capabilities of others. Oracle Cloud provides access to high-performance computing servers and clusters that are designed to perform complex, resource-intensive calculations and very high speed. Scalable storage. Oracle Cloud offers a variety of storages, but even more, the possibility to scale them based on our needs. So it offers the ability to scale vertically, increase the resources of a single machine, and horizontally, add more machines to the cluster, based on computing needs. This allows you to address workloads that vary in size and complexity. Security and governance, to maintain the control and the security every time. Oracle Cloud refers to a set of practices, policies, and tools designed to ensure the security of data and resources on the Oracle Cloud platform, like data security, identity and access management, audit and compliance, etc. High integrity with vendors, which means that it doesn't matter which other cloud services are using because Oracle Cloud can combine with practically all the clouds in the market. And finally, data management and storage, which is the main topic of this presentation, and we will focus on this next. Before explaining how a data lakehouse is set up in an Oracle Cloud environment, I would like to take out a little tour through data architecture. For decades, data warehouse is a data management system that has been used in organizations to store, structure, and pre-process data. Data is stored in relational tables and organized in schemas that follow a defined model. Later, a new concept appears on the playing field, the data lake. Data lake is a data storage solution that allows organizations to store large volumes of data in its original format, without the need to previously structure it. It can contain structured, semi-structured, and unstructured data, making it highly flexible. Lately, the data lakehouse comes to combine the best of both worlds, the flexibility of a data lakehouse and the analysis capability of the data warehouse. In the data lakehouse, data is stored in its original format, but also can be organized and structured as needed for efficient analysis. Now, we can see the benefits of having a data lakehouse architecture. So, having a cloud-based data lakehouse impacts in a very positive way in the codes from the storage until the administration. It means that having everything in a repository impacts in the storage, data redundancy, administration, and data governance. Finally, and to finish this section, here you can see how Oracle suggests how to set up a complete data lakehouse architecture in an Oracle Cloud environment. The first step shows that it does not matter the data source. You will be able to load the data from practically any data source. Once we have selected our data sources, we need to bring all this data to our data lakehouse. So it can be through a data ingestion, a batch ingestion, bulk transfer, etc. It depends on our needs. So in the middle of this schema, it is represented how the data storage is. So we can see different ways of storage, like an autonomous data warehouse for structured data, or an object storage for other types of information like files, videos, or any other kind of archives. And the last part represents how we query this information. Since we have different types of data stored in our data lakehouse, we can query this information in different ways, creating reports or dashboards in our Oracle Analytics Cloud, using data science techniques, artificial intelligence services, etc. But all these features are possible not only because we have all the data in the same repository, but because the governance layer allows every time to keep all this data under control. Now, my colleague Enrique is going to present a use case in the Oracle Cloud.
Thank you, Jose. So I'm going to present the use case that we've prepared for the demo or the small POC for this data lakehouse scenario. For the POC, we've included here the key cloud components. Some of them, you have already seen them in the schema that Jose showed before, but we believe that these are the most important ones. So are the ones that we've included in the POC and that you will see in the demo afterwards. These 6 components are the autonomous data warehouse, which is database, but that's automatically managed by Oracle. So it's very useful to do quick queries and for automated management. Then we have the OCI data integrator, which is like the classical ODI, but on the cloud. So it provides the same utilities that the classical ETL had, but in the cloud. And we can here transform all the data and do all kind of real-time integration. Then we have the object storage, which is the place, as Jose was mentioning, to upload all the unstructured data like files, images, or videos. Then we have data science tool, which can be connected both to the database and the object storage, and it is used to analyze, predict, and do any kind of machine learning or artificial intelligence on top of this data. The analytics cloud, which is the more classical reporting tool, which has both the classic OBI and data visualization included in this analytics cloud tool. It's used to create dashboards, reports, and visualization. And finally, we also included the data catalog, which is the tool that we'll use to govern all the metadata of the organization, and it works through tags, custom properties, and glossaries, as you will see in the demo afterwards. So how we connected all of this, we used a sample database, in this case, the Microsoft AdventureWorks dataset, plus some manual files, and we loaded this sample database into the data autonomous database, in this case, simulating a data lake, and files to the object storage in the buckets. Then all this information, we transformed it using the data integrator and the data flows, and we stored it back to the database, in this case, already in a star schema way, simulating the data warehouse. And then we can consume all this information both using the data science tool and the Oracle Analytics Cloud. As I was mentioning before, we can govern all of this data platform using the data catalog. And now my colleague Luis will make the demo to show a little bit more how all of this is working.
Well, in this demo, I will show you how easily works a data lakehouse in OCI. We have created a small POC using different cloud components to simulate this architecture. To do it, our case has been the AdventureWorks dataset from Microsoft, where it has been stored in an autonomous data warehouse. Moreover, we use the object storage for storing table and the data flow for ETL. After this, we have looked how everything interacts using the visual tool, the Oracle Analytics. For the data governance, we use the data catalog and the data science component for analyzing. First of all, I will show you how was all the raw data in the original 10 tables. And here we have the original ones that we transformed to finally get the star schema design just using 5 tables. Now we are going to go to the OCI data integrator, specifically the data flows, where we can use it as a traditional ETL because it can help us to extract, transform, and load our data. And we go to our project AdventureWorks, and here we have all the data flows. And I will show you the DIM product one. In this case, we have 3 sources, each one for one table. And well, here we have some expressions that can help us, for example, in this case, to change the data type using the function cast. And we introduce 2 joins. For example, this is a left outer join between the product category and the product table. And here another join to join the last join and the table product model. However, this is not the only way to load data instead of loading from a traditional database, because we have buckets that it's like a container for storing objects in a compartment. And here, well, we have our bucket, and here's where we upload our objects. As you can see, we have like different kind of objects. And well, after we upload, we go in this case to this data flow, and I will show you that you can upload directly from the object. We just need to choose the data asset from OCI objects and then the name of the bucket and the data entity we want to use it in this case. Moreover, it's very important to choose the target because will be the place where all the data is going to be stored. In this case, we decide the data asset, the data warehouse from the Oracle Cloud interface, where all the product will be stored. And then the schema target and the name of the new table will be the dim product. And then we need to compile, execute all the data flow. And if everything is correct, the data will be stored correctly in the new table. When we have all the data more or less structured, we use an Oracle Analytics Cloud to have a more easy way to analyze the data in a visual way. But before to create any graphics, first of all, we need to define the 3 layers that make it up in the semantic model: the physical, the logical, and the presentation. And in each layer, we need to do few important things. If we go to the physical layer, here we create an alias in each table, and then if we go to the sales table, we just need to create the star schema design connecting all the alias, like in these pictures. Then in the logical one, we go another time to the sales table and we change some of the aggregation rules of some attributes of the table. For example, here we can change it, and after that, when we are starting creating some graphics, this can help us to have like different results. And then in the last one, the presentation layer, well, here we just need to revise everything is correct, the data types and these things. Then we check if we have some errors, and if everything is correct, we can deploy the semantic model. When we have the model in a correct form, we can create a workbook based on the presentation layer that we can start creating some graphics like this. And in this case, this circular graphic is about the unit price discount, the name and the city, and it's very simple to modify the form. We just need to come here and change. You have plenty of options. And then if you want to change some of the values, just need to move here and automatically is update the results. As you can see, is a very easy way to create and modify graphics, and you have like a lot of options and different ways to do it. And now I'm going to introduce you the data catalog, because can simplify the access to data source and strengthens data governance by improving the discoverability of data just using some tools of data catalog. When you open your data catalog, the first thing that appears to us is a dashboard that shows some information as a widget, but it's important to know that we cannot add more widgets to the dashboard. The first widget has some quick options, for example, browse data asset, create data assets, and more. The second are types of data assets in use in this data catalog, for example, 50% from an autonomous data warehouse and the other 50% from an object storage. And then the next one is the wall of popular data catalog tags. Here we can see in a more visual way the quantity of each tag in the data catalog, since a tag is like a sticky note that you put on a data and can help you to identify and organize your data by adding some keywords. Moreover, you can add like more than one tag per element. The other element is the custom properties, are levels that you can add to your data to be more specific and can give you like an extra description or category. Here we have all the custom properties that I create, but I want to comment the data owner, for example. Here we have some information of these custom properties, and one cool thing that you can do it is to predefine some values of the data owner. For example, here we have Enrique, Luis, and Jose Manuel. And the way this works is you, for example, search one table, in this case the address, and here we have like the default properties that the data catalog gives you, but in this part we have like custom properties, each one with the description that you can see before, and the values of some custom properties. And one little thing to comment here is the place where you write the tags that we commented before, and you can add more than one, and then this appear to this graphic. And the last element is the glossary. Well, it's like a little dictionary that can help us to define and organize some data. And it's a good option when there are part of the company that they are not closely related in some technical words, so they can check it here before to write on the data catalog. Now I'm going to explain you the last part of this demo, that is the data science part, that it's really good when you want to deep into some data. And here we have like some environments, kernels ready to use. However, in our environment, we just wanted to know how easy it is to use the data of our object storage stored in a bucket. First of all, we import some important libraries like Panda because it's the most used one. And then we do the connection between our environment and the bucket. We define the bucket name, the namespace, and the file name. And then we import the document. And well, here we check if everything is correct with some functions. And well, as you can see, everything works properly. And well, I hope you enjoy the demo, and thanks for your attention.
Thanks so much, Luis, for this interesting demo. Let's go to the wrap up and the conclusions. So we have seen how Oracle provides a cloud environment that is fully competitive in the market, providing all the services needed to build a robust data platform, and where it is possible to build different types of architectures. In addition, Oracle Cloud has many more services and components to the ones that we've seen in this demo, no? So it's something even much bigger than this, no? But of course, in this demo, we have only focused on showing the components that are used to build a data lakehouse, but it's possible to do even more things, no? We have seen also how the data lakehouse architecture is the next step, good evolution from the data lake architecture, no? Because at the end is combining the flexibility of the data lake with the analytical capabilities that the data warehouse provides, no? So we have seen how this integration between the data lake and the data lakehouse, no, in this case, is success. We have transformed source system, no, in this case, a relational database, the sample database that we used for the demo, into a more streamlined and efficient star schema. But thanks to the data lakehouse architecture, we would still be able to access both the source and the transform tables, no, so that each of them can be used accordingly. The source tables could be used for more operational purposes. For example, for real-time analysis, no, if the source system was replicated to the data lake using, for example, the Golden Gate mass extraction tool, no, or if we use the data warehouse tables, no, of course, for more analytical purposes. And this is something that we've clearly seen, no, in this project. Also, we have seen that building data lakehouse in Oracle Cloud, it's possible to combine multiple data sources, no? Both database tables plus external files. We've shown the scenario that's probably the more typical, no, using a CSV file, but it's also possible to combine sources such as images, videos, more complex kinds of structured and semi-structured data. And something that's also possible, and that we have not maybe shown it too much in the demo, but we've also investigated that it's super flexible. It's interacting Oracle Cloud components with components from other vendors, no? So building an architecture that's not 100% based on Oracle Cloud, but also interacting with some components, for example, the database or the data sources, no, from other vendors. Then we have seen how is it possible, no, to analyze all of this data with two different tools. First of all, with Oracle Analytics Cloud, which is the classical business intelligence tool that Oracle has provided for a long time already. No, it's an evolution from OBI that now also has the data visualization part, which is easier for the end users to understand. And there it is possible to visualize and analyze all the data. And we have also shown how it is possible to connect the data science tool to this data platform, to do more complex analysis, to do machine learning on top of it, to create Python scripts on top of these data sources. So that's also something that we've seen here that provides a lot of flexibility. We have also seen how we can use the data integrator as an ETL tool, which is the classic ODI that we've been using on premise for a long time, but now it's in the cloud. It's possible to manage data in a more efficient way, because we can connect both to databases, but also to the object storage to get data from the different files, and then it provides all the classical ETL capabilities that the ODI had. So it is possible to use this data integrator to do all kind of complex ETL developments. And finally, we have seen that also we can provide an effective data governance with this data lakehouse architecture, as the Oracle Cloud also provides a tool that's the Oracle Data Catalog, which has features like tags, custom properties, glossaries, which allow you to analyze all the metadata and provide effective data governance to the environment. And this is it. Thanks so much. Hope you enjoyed it. Just a last thing to mention here. In ClearPeaks, we've been doing blogs related to Oracle. We have different ones. For example, we have a blog that explores the September 2023, which is the latest OAC release. Here we have a clear description of all the new features that have been released in this September, and it's an interesting one to keep everyone posted of the new updates here. Then we have a one related to create custom machine learning models in Oracle Analytics. I think this is also a very interesting one that shows a specific use case that could be applied to other scenarios. And finally, we have one related to this new semantic modeler that is the new modeling tool for top of the data warehouse, substituting the classical RPD admin tool. It's completely redesigned, much easier also for the users to use. And I think this is also a very interesting article. So that's it from my side.
Again, thank you very much, all the attendees, for joining us today, to all the presenters and speakers. And stay tuned for our next webinar for the journey to the cloud with the next technology. Thank you very much.